welcome to NJEE classes. So today we're going to discuss is about integration. Okay, so basically integration is most important part for JEE physics if you are preparing for IIT-JEE as well as for if you are preparing for advanced JEE advanced NEET AIIMS. Okay, so integration is basically a very integral part of physics because in many questions you will came across integration and very high-fi integration will be used over there in advanced problems. All right, so it is very important to have a great in-depth analysis and understanding of integration. All right, so today I will going to try to make your concepts of integration easier for you. Okay, and if you didn't have subscribed the channel, then just click on the subscribe button. And as well as if you have any comments, if you have any views to share about the channel as well as the videos and suggestions, then kindly comment over there on the chat box. Okay, all right everyone, so let's discuss about integration. Let us start with very basic definition. Integration basically means to sum up, okay, to add up, okay, or to sum up. So integration has a very clear meaning, very simple meaning, that is to add up or to sum up, right? So have you seen the picture over there? What is happening in this picture? There are four parts over there, okay, and all the parts are joined together to form a complete circle over there, right? So it means that suppose area of this circle, let it be A1, this part, area of this part, let it be A2, area of this part, let it be A3, and this part's area will be A4, correct? So if I'm going to find out the total area, so what it would going to be? So that is going to be equal to A1 plus A2 plus A3 plus A4, correct? So that is going to be A1 plus A2 plus A3 plus A4, sum of all the areas. Or we can say that that is going to be equal to summation of areas, correct? And the summation sign is changed to the integral sign. So that is going to be also be equivalent to integral of dA. Clear? Okay, so integral of dA or integral of A, where dA is said to be a very small area. dA is said to be a very small area. So that is how we will define the integration. Integration basically means to add up or to sum up. Just by an example, we are having a picture over there. Okay, so on the basis of that, we have a clear understanding of integration. And this is a sign of integration. Okay, summation is replaced by this sign. Okay, so this is the sign of symbol of integration. This is what this is the symbol of integration. Okay, all right. Next, another example we are having. Suppose this is the example we are having. Okay, suppose this is a rectangle we are having, and suppose we are required to find the area of this rectangle, correct? So what we will do, we will just take a very small area on this rectangle. So let us suppose a very small area on this rectangle, and this small area is going to be dA. Okay, dA means very small, d means very small. Okay, or we can say that it can be delta A. Okay, so the complete area if you are required to calculate, so total area will going to be equal to sum of all the small areas, right? So that is going to be equal to delta A1 plus delta A2 plus and so on, correct now? So that is going to be equal to what? Summation of delta A, or it can be equivalent to integral of delta A, correct? So total area is going to be equivalent to integral of delta A, or it can be equivalent to integral of D. Okay, so that is how we can take the total area, complete area over there. So in the same way, if you are going to calculate any quantity, so if you know a very small quantity over there, okay, and you are requiring the complete quantity, then what you should do, you should simply integrate that, right? So basically, if I explain you this by an example over there, so suppose if any quantity q is related as suppose I into dt, correct? So if any quantity q is related as I into dt, so basically dq, small charge, Okay, so complete quantity Q can be equivalent to integral of dq, or we can say that complete quantity Q can be equivalent to integral of I into theta. Correct? So that is how on the basic level we can define the integration. This is how we can calculate any of the quantity on the basis of integration. All right. So I hope you understand the very basic things. What is integration is, what is a symbol of integration. Okay. And now we should understand that how to calculate integration. All right. So another definition, if I define integration, so if fx is a function and differentiation of fx is going to be equal to gx, okay, then integral of gx with respect to x will be equal to the function itself. This is a very important property of integration. This is the important property. What is the property? See, once again, if fx is a function, then dy dx of fx is going to be equivalent to gx. Okay, then integral of gx with respect to x is going to be equal to the function fx itself. Okay, and plus c is a constant. C is a constant. Okay, so that we will came to know later on that why does this constant is over there. Okay, first of all, you should remember this property that integral of differentiation of a function is going to be equal to function itself. Here, so what is gx? Gx is basically in differentiation of fx, right? So I can also write it as integral of dy dx of fx, because gx can be written as dy dx of fx, right? With respect to x is going to be equal to the function fx itself plus a constant term c. So this property you should remember. All right. So let us suppose if I give an example on the basis of that. So if I give an example on the basis of that, let's suppose integration of, sorry, suppose differentiation of sine x. What is that? That is equal to cos x. Correct. So if I'm going to write down the integration of cos x, if I do the integrate of this term, then I will definitely got what? My function itself. Correct now? So this expression, this is my fx and this is my gx. Correct. So integration, what is my property? My property is integration of gx with respect to x is going to be equal to function itself plus c. So in the same way, integration of cos x with respect to x, because my gx in this case is cos x. So that is going to be equal to my function itself. What is my function? That is sin x only plus c. Correct. So that is how we can explain the integration. Another example, suppose we are having differentiation of tan x is going to be equal to sec square x, correct? So now what we will do, if I integrate this term, then I will definitely get the function itself. So if I integrate the differentiation of tan x, it is sec square x. So integration of sec square x with respect to x is going to be equal to my function itself, that is tan x plus c. Clear now? So that is how we can proceed on with that property of integration. We can find out its value over there. Or we can also say that integration is antiderivative. Integration is antiderivative. Integration is basically antiderivative. Okay, derivative or differentiation is the same term. So integration can also be referred to as antiderivative. All right. Okay. Next, we will going to understand the integrations of basic formulas that we will going to use in physics. Okay, very often we will come across these formulas, so we must have a clear understanding of implementation of formulas. So the first formula in this regard is integration of x to the power n dx. Correct. Again, what we are having? Again, we are having integration of x. X is a variable to the power n. N is a constant. Correct. So again, variable to the power constant. So its formula is quite different. So that is going to be equal to x to the power n plus 1. upon n plus 1. Okay, and plus a constant term is always there, that is c. All right. So integration of x to the power n dx is going to be x to the power n plus 1 upon n plus 1 plus a constant term c will be there. And what is that? Variable to the power constant, right? So n belongs to a constant, n belongs to constant, or n belongs to a real number, but n cannot be equal to minus 1. This you should remember. In this formula, while implementing this formula, n will not be equal to minus 1. This is very important. Okay, why this is important, we came to know about it, but n cannot be equal to minus 1, right? And what is the differentiation of x to the power n? So basically, we have already studied in the previous video that differentiation of x to the power n is going to be equal to what? Nx to the power n minus 1, correct? And integration is what? X to the power n plus 1 upon n plus 1, means power is raised by 1 and in denominator power plus 1. All right. Let's see some examples on the basis of that. Yes, please. The first example, integration of x square dx, right? So what is the n in this case? In the first case, n is going to be equal to 2, correct? So we can definitely apply the first formula, that is x to the power n plus 1 upon n plus 1. So here also x to the power 2 plus 1 upon 2 plus 1, that is going to be equal to x to the power 3 upon 3 plus c. All right, a constant term is always there. Next, x to the power minus 3. Okay, in minus 3 it is applicable because it is only not applicable only in one case, that is when the n is not equal to minus 1, correct? But in the case of x to the power minus 3, it is definitely applicable, right? So it is going to be equal to x to the power minus 3 plus 1 upon minus 3 plus 1, and x to the power n plus 1 upon n plus 1 plus c. So that is going to be equal to x to the power minus 3 plus 1 is what? X to the power minus 2 upon minus 2 plus c. This is your final answer. All right. Next is what we are having, integration of x to the power minus 3 by 2 dx. Okay, so this is also solved by the same formula. So what we are having, constant is what? Minus of 3 by 2, right? So x to the power minus 1 upon minus 3 by 2 plus 1, correct? So it is going to be equal to x to the power minus 1 by 2 upon minus 1 by 2 plus a constant c is always there, right? So it is going to be equal to minus 2 x to the power minus 1 by 2 plus c. This is going to be your final answer, correct? So I hope you understand how to implement the very basic formula, very first formula. Let's see another example. Yes, please. Integration of root x dx. So what I can write, integration of root x means integration of x to the power 1 by 2 dx, correct? So what is n? 1 by 2. So that is going to be equal to x to the power 1 by 2 plus 1 upon 1 by 2 plus 1. So it is going to be equal to x to the power upon 3 by 2 plus c, correct? So that is how we are going to have the final answer. All right. Next, what we are having, integration of 1 upon x to the power 5. So 1 upon x to the power 5 can be written as integral of x to the power minus 5 dx, correct? So again implement the formula. So we are having x to the power minus 5 plus 1 upon minus 5 plus 1 plus the constant term c. So it is going to be equal to x to the power minus 4 upon minus 4 plus c. That is your final answer, correct? All right. Next example, integration of 1 upon root x. So that is going to be equal to integral of x to the power minus 1 by 2 dx, correct? So again we will apply the same formula. So what is that? X to the power n plus 1 upon n plus 1. So x to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus a constant c is also there, correct? So that is going to be equal to x to the power minus 1 by 2 plus 1 is what? Plus 1 by 2 upon plus 1 by 2 plus c. So it is going to be equal to 2x to the power 1 by 2 plus c. It's going to be your final answer. And remember that c is always there in your final answer. Okay, c always comes up in your final answer. All right, so this part is clear. Another example, x to the power 5 by 2 dx. So it is going to be equal to x to the power 5 by 2 plus 1 upon 5 by 2 plus 1 plus c. Again, we will apply same formula. Integral of x to the power n dx is x to the power n plus 1 upon n plus 1. So that is going to be x to the power 5 by 2 plus 1 is what? 7 by 2 upon 5 by 2 plus 1 is 7 by 2 plus c. Correct? So that is going to be equal to 2 by 7 x to the power 7 by 2 plus c. That is your complete answer. Correct? So that is how we can proceed on with the first formula, that is integral of x to the power n dx. That is simply equal to x to the power n plus 1 upon n plus 1. All right. Next, we have to understand some few properties of integration. Okay, the very first property is that integral of k means a constant, times of dx, fx is a function, k is a constant, okay, dx. So it is going to be simply, so k terms, so k comes out, so we are having k times of integral of fx dx, correct? And plus, when you integrate it, then after constant term will always arise, that is c. So while integrating, constant terms will comes out of the integration, it will not going to integrate with the function. All right, just as similar to the differentiation. So here an example we are having, so integral of 2 times of x, right? So 2 will not going to integrate, so 2 will comes out. So 2 will comes out, so we are having only integration of x to the power 4 dx, correct? So it is equal to 2 times of, yeah, again we can apply the same formula now, x to the power 4 plus 1 n plus 1 upon 4 plus 1 n plus 1 plus c. So it is going to be equal to 2x to the power 5 upon 5 plus c. That will going to be your final answer. Correct? All right. Next, what we are having the property. Next property is that when we are having the integral of the sum or differences of two functions, then what happens again? The integration will be going through the all the functions. Okay. So integral of x square plus x to the power minus 2 dx is an example. So integral will go into all the functions. So we are getting integral of fx dx plus minus integral of gx dx. Correct? So here in the example, what we are getting integral of x square dx plus minus integral of x to the power minus 2 dx. Okay, so it is going to be equal to, again apply the same formula, x to the power n plus 1 upon n plus 1, so x to the power 2 plus 1 upon 2 plus 1 plus minus x to the power minus 2 plus 1 upon minus 2 plus 1 plus a constant arises c. So it is x to the power 3 upon 3 plus minus x to the power minus 1 upon minus 1 plus c. So that will going to be your complete. Correct? So this is how we can proceed on with the numericals. All right. So these two properties are very important. First is what? Whenever the constant is there along with a function, then just take out the constant, okay, and then just integrate the function as it is. All right. And whenever you are having two functions or more functions in addition or subtractions, then the integration will be substituted to each functions separately. All right. That is how we are going to have the final answer. Okay. Next, we will have to define basic formulas on the basis of property, that is integration of differentiation of function with respect to x is going to be equal to fx function itself plus a constant term c. So on the basis of this part, I'm going to define you the certain sets of formulas that you have to remember directly. Okay. So for that, you must have to remember all the formulas of differentiation, right? So what is the first formula of differentiation? Differentiation of e to the power x is equivalent to it. So if I integrate this term, correct? So what I am getting, the function itself, that is e to the power x itself plus constant c is also there. All right. Next, integral differentiation of a to the power x is equivalent to what? A to the power x log of a on the base e. Correct. A stands for a constant. Okay, so log a on the base e is basically a constant term. So if you integrate the RHS part, that is integral of a to the power x into log of a on the base e, right? So log a on the base e is a constant term, right? So it can be taken out of the integration. So we are having log of a on the base e integral of a to the power x dx. This property we have already studied, right? So it is going to be equal to what? Integral of a to the power x dx. So it is going to be equal to a to the power x, right? So it is going to be equal to a to the power x, correct? So if I just multiply it over there, cross division, so integral of a to the power x dx is equal to a to the power x, cross multiply these terms divided by log of a on the base e, correct? So that is how we are having the formula for integral of a to the power x. So that is simply going to be equivalent to e to the power x multiplied by log of a on the base e, correct? All right. Next, we are having the differentiation of log x on the base e. So log x on the base e is going to be equal to what? 1 upon x, right? So integral of 1 upon x dx is going to be equivalent to the function itself, that is the log x on the base e, plus the constant term c is also there. Is that clear? Okay, and now that I have told you that here is what integral of 1 by x. Integral of 1 by x means x to the power minus 1. What is there? X to the power minus 1, right? So previously we have discussed the formula, what? X to the power n, right? So I have told you that we cannot use n equal to minus 1. Okay, so do you understand the reason why I didn't use n equal to minus 1? Because integral of x to the power minus 1 dx is going to be equal to log x on the base e. Clear? So that is why we will not use that formula here. So you should remember directly that integral of 1 upon x dx is going to be log x on the base e plus c, and not to use the formula for x to the power n over here. All right. Okay. What is the next one? That is d by dx of sine x is equal to cos x, right? So similarly, the d by integral of cos x dx is going to be equal to c, correct? Differentiation of cos x is equal to minus sine x. So integral of sine x, okay, so minus can be taken out and multiplied the RHS part, so that is going to be equal to minus of cos x. Okay, basically integral of minus sine x is equal to cos x, so minus can be multiplied to RHS part also. So integral of sine x is equivalent to cos x. Differentiation of tan x is sec square x. So similarly, integral of sec square x is going to be equal to tan x plus c. In the same way, integral of differentiation of cot x is equal to minus cos x square x. So integral of cos x square x dx is equal to minus of cot x plus c. Next, differentiation of sec x is equal to sec x tan x. So integral of sec x tan x is going to be equal to sec x plus c. Differentiation of cos x is equal to minus of cos x cot x. So integral of cos x cot x is equal to minus of cos x plus c. Correct. So that is how we will define the basic formulas. So what you should do, just revise and remember all these formulas before proceeding towards the numericals and all the properties that we have discussed so far. Okay. So differentiation of e to the power x is equal to e to the power x. So integral of e to the power x is equal to e to the power x plus c. Differentiation of e to the power x is equal to e to the power x log a on the base e. So integral of a to the power x log a on the base e is equivalent to a to the power x basically, but we can take the log a on the base e common out, and when we cross multiply it, so integral of a to the power x dx is equivalent to a to the power x divided by log a on the base e plus the constant term c will also be there. Okay, then Differentiation of log x on the base e is equal to 1 by x. So integral of 1 by x dx is equal to log x on the base e. And remember not to apply x to the power n formula in this particular case. This is a very restricted case. Next, d by dx of sin x is equal to cos x. So integral of cos x is basically equal to sin x plus c. Next, differentiation of cos x is equal to minus sin x. So integral of minus sin x is equal to cos x. So cos x sin x is equal to minus cos x. Integral of sin x is equal to minus cos x. Differentiation of tan x is sec square x. So integral of sec square x dx is equal to tan x plus c. Differentiation of cot x is equal to minus cos x square x. So integral of cos x square x is equal to minus of cot x plus c. Differentiation of sec x is equal to sec x tan x. So integral of sec x tan x is equal to sec x plus c. Differentiation of cos x is equal to minus cos x cot x. So integral of cos x cot x is equal to minus of cos x plus c. Clear? So all these formulas are pretty important. So you should just go through them once and revise them properly. Okay. So let's proceed on to the numericals on the basis of that. Yes, please. So the first one, integral of 4x to the power 5 dx, right? So by the help of property, this 4 will comes out. So what we are having 4 times of integral of x to the power 5 dx, because whenever constant term is there, it can be taken out of the integral. So it is going to be equal to 4. Yes, now we can apply what formula? X to the power n, correct? So what is that? X to the power n. Integral of x to the power n dx is equal to what? X to the power n plus 1 upon n plus 1 plus c. Correct now? So just apply that formula. So what we are having? X to the power 5 plus 1 upon 5 plus 1 plus c. So it is going to be equal to 4 x to the power 6 upon 6 plus c. This is your answer. Correct. Next, integral of 3 sin x dx. So again 3 will taken out of the integral. So it is equal to 3 times of integral of sin x dx. So what is the integral of sin x? That is minus cos x, right? So 3 times of minus cos x plus c. So it is minus 3 cos x plus c will be our final answer. Correct. Next example we are having integral of sec square x dx upon 5. Again 1 upon 5 is a constant, so 1 upon 5 is taken out of the integral. So what we are having integral of sec square x dx. Correct. So it is going to be equal to 1 upon 5. Integral of sec square x is what? Tan x. Why? Because differentiation of tan x is sec square x. So integral of sec square x is tan x. So that will be your final answer. Correct. All right. Let's see another example over there. Integral of x cube plus 5x square minus 4 plus 7 by x plus 2 root x dx. Correct. So now what happened? Integration will be transferred to all the terms, right? So that is going to be equal to, first term will be integral of x cube dx plus the 5 will taken out of the integral. So 5 integral of x square dx minus 4 will be taken out of integral. Integral of minus 4 integral of dx plus 7 integral of 1 by x dx. 7 by x, right? 7 is taken out of integral. So integral of 1 by x dx plus 2 root x. 2 is taken out of integral. Integral of root x. Root x means x to the power 1 by 2 dx. Correct. So the first term, again apply x to the power n. Yes, so x to the power n plus 1 upon n plus 1. So x to the power t plus 1 upon t plus 1 plus 5 x to the power 2 plus 1 upon 2 plus 1 minus 4 integral of dx. Yes, please. So when you are calculating integral of dx, so can I express the integral of dx as like that? Integral of x to the power 0 dx. Can I write it down like that? Because anything to the power 0 is going to be 1. So I can write integral of dx as x to the power 0 dx. Correct. So now apply the basic formula x to the power 0 plus 1 upon 0 plus 1. Correct. Plus what we are having 7 integral of 1 by x dx. So this is a special case whose formula is what? Log x on the base e. Correct? Plus 2 integral of x to the power 1 by 2 dx. So 2 x to the power 1 by 2 plus 1 upon 1 by 2 plus 1. Correct? Now just solving this equation, so it will become x to the power 4 upon 4 plus 5 x to the power 3 upon 3 minus 4. Yeah, so x to the power 1 upon 1, so that is simply x. Okay, so remember that integral of dx is going to be equal to x itself, right? It will not going to be 0, it will going to be x plus 7 log x on the log 7, sorry, log x on the base e plus 2 times of x to the power 3 by 2 upon 3 by 2. Plus, at last you should just add a constant, so that will be your final answer. Correct? So this is how we can proceed on to this numeric. Next. Yes, please. So we can multiply the root x with all the terms in this case. So we are having integral of root x minus x root x into dx. Correct. So now what we are having? So it is going to be equal to integral of again x to the power 1 by 2 dx separated minus integral of c. Here we are having x to the power 1 and here we are having x to the power 1 by 2. So 1 plus 1 by 2 is going to be x to the power 3 by 2 dx. Correct. So it is going to be equal to x to the power 1 by 2 plus 1 upon 1 by 2 plus 1 minus x to the power 3 by 2 plus 1 upon 3 by 2 plus 1 plus c. So that is what we are going to have. Correct. So that is equal to x to the power 3 by 2 upon 3 by 2 minus x to the power 5 by 2 upon 5 by 2 plus c. Correct. So this is how we can proceed on with the numericals. Another example what we are having, integral of root x plus 1 by root x ka whole square. So just apply the formula. What you should do? A plus b ka whole square. So what is that? A square plus b square plus 2ab. Correct. So just apply this formula. So what we are having, integral of root x ka whole square dx plus integral of 1 upon root x ka whole square dx plus integral of 2 root x 2ab. 2ab means 2 root x into 1 by root x dx. Correct. So what happens over there? So here root x and root x will be cancelled out. So what we are left with, that is equal to integral of root x ka square is what? X dx plus integral of 1 by root x ka square is 1 by x dx plus 2 is taken out, integral of dx. Correct. So that is basically equivalent to what? That is basically equivalent to x to the power 1 here we are having. So simply x to the power 1 plus 1 by 2 by 1 plus 1 plus 1 by x, the special case, so its integration is log x on the base e plus 2 integration of dx is going to be x plus the constant term c is there. Right, so that is going to be equal to x to the power 2 upon 2 plus log x on the base e plus 2x plus c. All right, so that is how we will going to get the final answer. So I hope you understand how to proceed with the numericals on the basis of the simple formulas that we have already studied. Next, integrations using the following properties. 1 plus tan square x is equal to sec square x. 1 plus cot square x is equal to cos square x. Right. The very basic formula, first formula is that what we are having, integral of tan square x dx. Okay, so do you have any formula for tan square x? No. But we know the integration of sec square x, right? So what we should do, we should convert the tan square x in terms of sec square x. So I think I can say that tan square x can be equal to what? Sec square x minus 1. So put up its value over there. So what we are having, integration of tan square x means sec square x minus 1 dx. Correct. So now if I integrate this term, so it is going to be equal to integral of sec square x dx minus integral of dx. Correct. So that is going to be equal to integral of sec square x dx is what? It is going to be equal to tan x minus integral of dx is what? X plus a constant of c. Correct. Next, integral of cot square x dx. So again, you can apply the same property. So cot square x can be equal to what? Cosec square x minus 1. Correct. Again, put up the values. So what we are having, integral of cosec square x dx minus integral of 1 dx. Correct. So it is going to be equal to integral of cosec square x is what? Minus of cot x. Correct. Minus integral of dx is what? X plus c. That is your final answer. All right. Next, integral of 1 upon sin square x into cos square x. Yes, please. So here I don't know if I reciprocal it. So what I am getting, integral of cosec square x into sec square x. So we don't have any formula for the multiplication of cosec square x into sec square x, right? So here in the numerator, what we are having, the 1, right? So can I use a property sin square x plus cos square x is equal to 1, right? This already you have studied in the 10th standard law. So let's put up in place of 1 in the numerator sin square x plus cos square x. So what you are getting? Sin square x plus cos square x upon sin square x multiplied by cos square x into dx. All right. So now what is that? It is going to be equal to integral of, separate the variables. So here we are having sin square x upon sin square x into cos square x plus cos square x upon sin square x into cos square x dx. Correct. So now what we will do? So that is going to be equal to sin square x cancel out. Here we are having sin square x cancel out, cos square x cancel out. So what we are having, integral of 1 upon cos square x is going to be equal to sec square x dx plus integral of 1 upon sin square x is what? Cosec square x dx. Right, and we know the direct formulas for that. So what is the formula for sec square x? It is simply going to be tan x. And what is the formula for cosec square x? It is minus cot x plus a constant c will also be there. So that is how we can find the solution and the answer for this. Sometimes you have to simplify those trigonometric functions. Okay. Yes. So what is the first one? Integral of 2 plus 3 cos x upon sin square x. So just separate the sin square x with all the terms. So first term we are having 2 times of 1 upon sin square x is going to be equal to what? Cos x square x. Correct. Plus 3 times of integral of sin x. Right. Sin square x dx. Correct. So the very first term is going to be equal to 2 times of, and dx is also there over there. So what is the integration of cos x square x dx? That is going to be equal to minus of cot x. Correct. Plus 3. See, here we are having cos x upon sin. Cos upon sin is going to be what? Cot x. And 1 upon sin is going to be equal to cosec x. Right. So cos upon sin square can be written as cot x into cosec x. Right. It is actually written as multiply by cot x dx. Why? You can write down in brackets that 1 upon sin x is equal to cosec x, and cos x upon sin x is basically equal to cot x. So this you must know, correct? So on the basis of that, we can write it down as minus of cot x plus 3 cos x into cot x dx, correct? So that is going to be equal to minus of 2 cot x plus 3 integral of cos x. Cot x is what? Minus cos x, right? Because cos x differentiation is going to be cos x cot x. So cos x cot x integration is going to be equal to minus of cos x, right? And plus c. So what is that? It is going to be equal to minus 2 cot x minus 3 cos x plus c. So that is going to be your final answer. Correct. Next. Integrations on the basis of these properties, cos 2x is equal to cos square minus sin square x, or cos 2x can also be equal to 2 cos square x minus 1, or it can also be equal to 1 minus 2 sin square x. Alright. So let's see about it. So integral of under root of 1 plus cos 2x, right? So just what we can say, cos 2x plus 1. So using the second property, let it be the first property, let it be the second, let it be the third. So using the second property, what we are having, cos 2x can be equal to twice of cos square x minus 1. So simply cos 2x plus 1 is equal to 2 times of cos square x. Correct. So just put up its value over there in the first equation. So what we are having, that is equal to integral of under root of 2 times of cos square x dx. Correct. So root 2 can be taken out. So root 2 can be taken out because root 2 is a constant. So integral of under root of cos square x is what? Cos x. So cos x dx. So it is going to be equal to root 2 integral of cos x is what? Simply sin x plus c. This is a final answer. Alright. Next, integral of under root of 1 minus cos 2x. So which property I should use? I think I should use the third one. The third property is what? Cos 2x is equal to 1 minus 2 sin square x. Correct. So basically 1 minus cos 2x is equal to 2 times of sin square x. Just put up its value. So what you are having? You are having integral of under root of 2 times of sin square x, because this whole term can be replaced by 2 times of sin square x. So that is going to be equal to root 2 can again be taken out under integral of under root of sin square x is going to be sin x dx. Correct. So integral of sin x is what? Minus cos x. So it can be minus of root 2 cos x plus c. So that is how you can have the final answer. Alright. Okay. Next, integration on the basis of simplification. Okay. So let's see how does integration is being performed on the basis of simplification. The very first example, we are having integration of 1 upon 1 plus sin x dx. So already you know how to simplify. Okay, so how we can simplify? We can just multiply and divide the term by changing the sign of denominator, right? So we can just multiply and divide the term by changing the sign of denominator in between. Okay, so in this way we can simplify it. So we can just do it like that: 1 upon 1 plus sin x. Okay, multiplying it by 1 minus sin x upon 1 minus sin x. Clear? So if I do this like that, so there is no impact on the equation, because in equation still remains same. 1 minus sin x, 1 minus sin x will be cancelled out, so equation still remains same. So no issues in that. But what we are getting integral of, in the numerator we are having 1 minus sin x divided by 1 plus sin x into 1 minus sin x. So it is a plus b into a minus b. So do you know what is a plus b multiplied by a minus b? That is simply a square minus b square. So it is simply 1 ka square 1 minus sin square x dx. Correct? So that is going to be equal to integral of 1 minus sin x upon 1 minus sin square x is what? Cos square x. Because sin square x plus cos square x is 1. So 1 minus sin square x is what? Cos square x. Now again, separate the variables. So here we are having 1 upon cos square x dx minus integral of sin x upon cos square x dx. Correct? So 1 upon cos square x is basically what? It is sec square x, right? So integral of sec square x minus, again, sin upon cos. So sin upon cos is what? Tan x, and 1 upon cos is what? Sec x, right? So can I write it down like that? Sec x multiplied by tan x. How I have written this? Sin x, there are two cos x in denominator in multiplication. So sin upon 1 cos is what? Tan x, and 1 upon cos is what? Sec x. So that is why I can write it down as integral of sec x into tan x into dx. So that is going to be equal to integral of sec square x dx. So that is what? Tan x minus sec x tan x is what? Sec x plus a constant term c is there. So that is your final answer. Correct. So that is how we can proceed on with the numericals based on the integration on the basis of simplification. All right. In the same way, we can also do the another question. Again, the same thing we can do. Just multiply and divide by the changing the sign of denominator in between. Okay. So we are having sin x upon 1 plus sin x multiply. Yes. So how we can multiply? 1 minus sin x divided by 1 minus sin x into dx. Correct. So that is going to be equal to integral of. Mhm. So just multiply sin x with the complete terms. So we are having sin x minus sin square x divided by 1 minus sin square x, 1 plus sin x into 1 minus sin x. That is going to be equal to 1 minus sin square x. Correct? Dx. So now that is going to be equal to integral of, yes please, sin x minus sin square x divided by 1 minus sin square x is what? Cos square x. We have already seen that. Right. So again, now separate the variables. So we are having integral of sin x upon cos square x dx minus integral of sin square x upon cos square x dx. Correct. So again, what we are having? Sin x upon cos square x. So sin x upon cos x is what? Tan x, and 1 upon cos x is what? Sec x. So the first term is written as like sec x into tan x minus the second term is written like that, sin x upon cos x is tan x, so it can be written as tan square x dx. Correct. So again, for the second term, what we can use? Tan square x. So for tan square x, what we can say? 1 plus tan square x is equal to sec square x. So tan square x is equal to sec square x minus 1. So just put up the values over there. So what we are getting? The first term, integral of sec x tan x is what? Sec x, right? Integral of sec x tan x is basically sec x plus, oh sorry, minus integral of tan square x can be written as integral of sec square x minus 1 dx. Correct. So here we are having the sec x minus integral of sec square x dx minus integral of 1 dx. So 1 dx means dx. Correct. So it is going to be equal to sec x minus integral of sec square x. Integral of sec square x is what? Tan x minus integral of dx is what? X plus c. Correct. So just multiply it. So what we are having, that is going to be equal to sec x minus tan x plus x plus c. So that is how we can proceed. All right. Okay. Next. Again we can simplify that. So integral of sec x upon sec x plus tan x dx. So again simplification. So what we will do, integral of sec x upon sec x plus tan x multiply by sec x minus tan x upon sec x minus tan x. All right, dx. So in the numerator, what we are having? In the numerator, we are having integral of sec square x minus sec x into tan x. And in denominator, again, we are having a plus b into a minus b, right? So it is going to be a square minus b square. Correct? Now what we can use? We can use the property. What is the property? 1 plus tan square x is equal to sec square x. Correct? So I can say that 1 is equal to what? So 1 is equal to what? Sec square x minus tan square x. Have we got it? So I think this term I am getting in the denominator, right? So just put up its value. Just put up its value in this equation. So what we are getting is going to be equal to integral of sec square x minus sec x tan x into dx. Correct? Because sec square x minus tan square x is going to be 1. So what we are having, that is going to be equal to integral of sec square x dx minus integral of sec x into tan x dx, right? So what is the integration of sec square x? That is simply tan x minus sec x tan x is what? Sec x plus c. So that is how we can have the final solution. All right. So I hope you understand the very basic gist of how to do the integration of basic formulas, right? Next section of integration is what? Integration by substitution. All right. So let's discuss about integration by substitution. Substitution, you understand, substitution means we have to put some other value of a function. Okay, substitution means we have to substitute a value for a given function. That is the meaning of substitution. Okay. So in this case, the very first case, see the very first case, see f dash x means differentiation, right? So just see the very first phase, what is written over there in the first case. We are having integration of fx into f dash x dx. What we are having? Integration of fx into f dash x dx. Okay, so I'm showing you the examples where to implement integration by substitution basically. Okay, I'm just showing you the examples of where to integrate the integration by, where to apply the integration by substitution. This is what I'm going to show you. Okay, so the very first case, what is happening? Integral of fx multiplied by f dash x into dx. F dash x is what? Remember that f dash x is basically the differentiation of fx. Differentiation of fx. All right. So basically what we are having, integral of fx into f dash x dx is going to be equal to what? Okay, all right. So this is the first case in which we can apply the integration by substitution. How to apply, how to manage that, I will tell you later. Okay, but remember that what we have to apply, where we have to apply in the following formats that I have shown you. The first format is integral of fx into f dash x, means we are having the function in the numerator as well as its differentiation is also there in the numerator. For example, is shown over there in your screen. This is the example shown. So I think x square plus 1, if I take my function, so if I differentiate x square plus 1, so what I will get? 2x dx I will get, right? So it means that my function is x square plus 1 and my differentiation is 2x dx. So I'm having the function as well as differentiation in the numerator. Next example, I am having function to the power something multiply by differentiation of the function dx, this format. Example, x square plus 1 to the power 5 multiply by 2x dx. X square plus 1, if I take my function, then differentiation of x square plus 1 is what? 2x dx. Correct now? So I am having my function to the power something multiply by its differentiation dx. Clear? Next example, we are having I am having my function, third example, I am having my function in the denominator and my differentiation in the numerator, right? So for example, I have got cos x upon sin x. So if I take sin x my function, then differentiation of sin x will going to be cos x, right? Cos x dx. Function is in denominator and my differentiation is in numerator, right? Again, denominator function to the power something multiply by differentiation, correct? Like this, cos x upon sin x ka whole square dx. So sin x, if I take my function, then cos x dx will be its differentiation, correct? No. Next format is what? If my function is inside some other another function, suppose f of gx, okay, multiply by g dash x, right? So I'm having a function inside another function, okay, and in multiplication I'm having its differentiation, like this example, integral of sin x square multiply by 2x dx. So if I take my function to be x square, so differentiation will be 2x dx, correct? So in all the formats, what we have to use, we simply have to use integration by substitution. In all the formats, we have to use simply integration by substitution. You understand? So the basic thing you have to understand from all these formats is that function can be anywhere. See in the numerator, okay, here the function can be denominator also. Here the function can be inside another function also. So function can be anywhere. But differentiation is always in the numerator. Have you seen that? F dash x dx, f dash x dx. All right. Yes, please. F dash x dx numerator, f dash x dx numerator, f dash x dx in the numerator, g dash x into dx numerator. Right. So you understand something? That function can be anywhere. Okay. So remember one thing. First thing, that function, your function can be anywhere. Means it can be numerator or denominator or inside another functions also, okay? But when you talk about differentiation, so you always have to think about differentiation only in numerator. Differentiation only is in numerator. So differentiation only arises in the numerator, okay? So that is how you should approach to the problems. So now we will see how to proceed on to the problems when we are having the kind of structure when we have to apply the integration by substitution, then how to find out the conclusions. Okay, how to find out the solutions. Okay, so for solution point of view, always remember. Let us suppose that my function is going to be some another function t. All right. So for solution purpose, what you should adopt, the first step is that my function, let it be equivalent to another function t. Okay, then differentiate that. So if you differentiate that, then you're what you're getting, f dash x dx is a differentiation of fx. So that is going to be equal to, in differentiation of t is going to be 1 multiplied by dt, correct? So what we can say, f dash x dx is going to be equal to dt. So this is direct differentiation. What kind of differentiation? Direct differentiation. So if you want to learn direct differentiation, just visit the previous slides. I have already explained you how to do the direct differentiation, previous video. All right. So what we are having? What we are having? We are having f dash x as some other function t. We are having fx as some other function t, f dash x dx as dt. So now whenever you are, whatsoever format you are having, just put up both these values. Okay, put the values of fx as well as f dash x in terms of t. Okay, so what you will do now, just put the values of fx and f dash x in the question, and then you will get the way how to solve it out. All right, so let's see by an example how to proceed on with that. Yes, please, the same example that we have discussed. Integration of x square plus 1 multiplied by 2x dx. So clearly, I think this is my function and this is my 2x dx is my differentiation, correct? So let us suppose that my function is what, x square plus 1. So x square plus 1, let it be t. differentiate the function. So that is going to be x square differentiation is what, and x to the power n minus 1. So 2x to the power 2 minus 1, so 2x to the power 1 dx plus differentiation of a constant term is 0. So there is no need to write it down. Differentiation of 1 is 0. It is going to be differentiation of t is 1 multiplied by d of that value. Correct? So 2x dx is basically equivalent to dt. Now put up the values. What values we have to put up? Mhm. So we have to put up both the values. This value, as well as we also need to put up the another value, that is 2x dx. This value. Okay. So just put up both these values in the above equation. Alright. So now if I just put up both the values in the above equation, so what we are getting? Mhm. So we are getting basically integration of x square plus 1 is what, t, and 2x dx is what, dt. X square plus 1 is replaced by t and 2x dx is replaced by dt. So it is what we are having. So we can easily solve this, right? Integral of t dt. So what is the formula? Again, we can apply integral of x to the power n over here, right? So t to the power n dt. Okay, so t to the power 1 dt. So it can be t to the power 1 plus 1 upon 1 plus 1. Correct? Plus a constant c is there. Correct? No? So what we are having, that is going to be equal to the power 2 upon 2 plus c. Right? Now just put up the value again. So now if I put up the values, what is the value of t? T's value is x square plus 1. So if I again put up its value, so what is we are having? X square plus 1 का whole square. T square means x square plus 1 का whole square by 2 plus c. So that will be your complete answer. Correct. So remember the steps. What you have to do, first of all, you have to identify what is your function and what is its differentiation. Okay. And remember that function will be anywhere, but differentiation must be in numerator. So like that we have said that x square plus 1 is my function, that will be t. Then 2x dx will going to be dt. Put up all the values. X square plus 1 is t, 2x dx is dt. So we are having t to the power 1 dt. So that can be easily solved by simply applying the formula x to the power n dx is equal to x to the power n plus 1 upon n plus 1. The very first form. Correct. So to the power 1 plus 1 upon 1 plus 1. So that is what? T square by 2 plus c. That is what? X plus 1, x square plus 1 का whole square by 2 plus c. Correct? Yes, please. Next one. So what we are having? Integral of x square plus 1 to the power whole to the power 5 into 2x dx. Right? So what we will do? My function is again x square plus 1. So let us suppose x square plus 1 is t. Differentiate that. So what is that? 2x dx is going to be equal to dt. I put up the values over there. So integral of t to the power 5 and 2x dx is what? Dt. Correct? So that is going to be equal to t to the power again n plus 1 upon n plus 1 plus c. So it is going to be equal to the power 6 upon 6 plus c. That is what my answer is. Clear? So on the basis of these two examples, I hope that you understand. Otherwise, let's see another example. Okay, so this I think we have already done. Okay, property is what? If integral of, there is a simple property also, one simple property on the basis of substitution also. So there is a trick over there that suppose if you are having an integral of fx dx is equal to gx. Okay, and suppose if x is replaced by, ax plus b. If x is replaced by ax plus b means linear function of x. Linear function means there would not be any power of x, x square root x, this would not be there. Only linear function of x. Linear function means x to the power 1 only in the expression. So if you are having dx is equal to gx and your x is replaced by ax plus b, right? Then integral of f of ax plus b dx can be simply equal to g of ax plus b and dividing the whole expression by coefficient of x. Dividing the whole expression by a coefficient of x. So dividing the whole expression by coefficient of x. Right. And plus c. So that will be our final answer. Okay, so integral of f of ax plus b is going to be equal to what? It is simply going to be equal to g of ax plus b divided by coefficient of x, that is simply a. Alright. Like for example, if I have to prove this, suppose. Okay, so let us suppose we have to find the value of integration of cos of 5x plus 4 dx. So this is what we have to find out. And what do we know? Integral of cos x is going to be equal to what? Plus sin x. Integral of cos x is going to be equal to plus sin x, right? This is what we know. Okay, and now what we are required to know? Integral of cos 5x plus 4. So see, x is replaced by ax plus b. 5x plus 4 is a replacement. So here also there is a linear power of x. Correct. So we can apply the trick. So what is the trick? It is simply equal to gx plus b, means sin x. We are having the difference integration. Cos 5x plus 4 is going to be sin of 5x plus 4. Okay, and divided by coefficient of x. What is the coefficient of x? It is 5 plus c. This is the final answer. Okay, but how does this answer comes up? Okay, so how does this answer comes up? So if I do the by the procedure, so this is by procedure, this actually comes up by the integration by substitution only. Okay, so what we will do in this basic expression, we will just assume that 5x plus 4 is going to be my t. All right, what I will assume that 5x plus 4 is going to be my t. So differentiate distance, we are having 5 times of dx is going to be 4 differentiation is 0 is equal to dt. Correct. So dx is going to be what? dt. Dx is going to be dt by 5. Put up its value in the first equation. So what we are getting? Integral of cos of 5x plus 4 dx to be equal to what? Integral of cos 5x plus 4 is t multiply by dx. Dx is what? dt by 5. Correct. So 1 by 5 is taken out because 1 by 5 is a constant, so it can be taken out. So integral of cos dt is what? Simply sin t. Let's see. Correct. That is simply going to be equal to sine. Now substitute the value of t again. So what is t? 5x plus 4. So it is sine of 5x plus 4 divided by 5 plus c. So again you are getting the same answer, correct? So basically what we have done directly is also the integration by substitution. Okay, but you can get the answer quickly, so you should remember that. If x is replaced by simply ax plus b, then integration of f of ax plus b is simply equal to g of ax plus b divided by coefficient of x. Correct now? Alright, so let us discuss all these examples. So I think it is also based on that property, sine of 2x. So 2x is also what? Linear function of x. So integration of sine x is what? Minus cos x. So it is going to be equal to minus of cos 2x divided by coefficient of x. Coefficient of x is 2 plus c. Correct. Next, 2x plus 5 to the power 6. So what we are expected? Integral of x to the power 6 we are expecting. So again what is happening? X is replaced by ax plus b. Correct. So now put up the value. So x to the power 6 integration is what? X to the power 6 plus 1 upon 6 plus 1, right? So that is going to be equal to 2x plus 5 to the power 6 plus 1 upon 6 plus 1 plus c. So it is going to be equal to x to the power 7 upon 7 plus c. So that is my final answer. Correct? Alright. Next is another example. 1 upon 5x plus 1. So basically we are expecting what? Basically we are expecting 1 by x dx. So what is its integration? It is simply log x on the base e plus c, correct? And here what we are having? Here we are having integral of 1 upon 5x plus 1. So simply again x is replaced by simply 5x plus 1 ax plus b, correct? So what is my integration? That is going to be equal to log of 5x plus 1 on the base e divided by coefficient of x, that is simply 5 plus c, correct? So that is going to be my final answer. In the same way, sec square 4x. So basically we know sec square x. Sec square x is what? 10x. So sec square 4x is what? 10 4x divided by coefficient of x. So coefficient of x is simply 4 plus c. Alright. Next. Yes, please. Integral of log x on the base e upon x. So in this case, what we will do? See, if I take my function to be log x on the base e, then what is the differentiation of log x on the base e? That is simply 1 by x dx, right? So I can take my function to be what? Let us suppose that log x on the base e is going to be my t. Differentiate that function. So 1 by x, log x differentiation is 1 by x dx. So it is going to be equal to dt. Now put up all the values over there. So what we are getting, it is going to be integral of t dt, correct? So that is going to be t square by 2 plus c. Integration of t dt is what? T to the power 1, t to the power 1 plus 1 upon 1 plus 1. So that is what? T square by 2 plus c. Again put up the value of t. T's value is log x on the base c. So log x on the base c ka whole square by 2 plus c. That is how we can have the final answers. Okay. Next, tan square x into sec square x dx, right? So I think if I take my tan x to be my function, then sec square x dx will be my the differentiation, right? So let us take tan x to be my function t. So differentiate it. So sec square x dx will going to be equal to dt. Now put the values. So what we are getting, it is equal to integral of tan square means t square into dt. So t square means to the x to the power n. So again t to the power n plus 1 upon n plus 1 plus c. That is t cube by 3 plus c. Now put the value of t. T is going to be equal to tan x, right? So it can be equal to tan cube x by 3 plus c. Correct? So that is how we can have the final answer. Alright. Next example. Yes, please. So you should just try by your own and then see the solutions. Okay, I'm just solving it right now. But first of all, you should try it by your own, okay, and then find the answers. So basically what we're expecting root x, okay, or x to the power 1 by 2. And it is what? Integral of 3x plus 4 to the power 1 by 2 dx. So what I will say simply, x is simply replaced by 3x plus 4, right? This I can use directly now. So now what we are having? So it is basically integral of yeah. So just x to the power 1 by 2 is what? X to the power 1 by 2 plus 1 upon 1 by 2 plus 1. Okay, so 3x plus 4 to the power 1 by 2 is what? 3x plus 4 to the power 1 by 2 plus 1 divided by 1 by 2 plus 1 and divided by what? Coefficient of x. So that is 3 plus c. Okay. So what we are having? 3x plus 4. Yes, please. So 3x plus 4 to the power 1 by 2 plus 1, that is 3 by 2 upon 3 by 2. So 3 by 2 can be written as like that, 3 by 2 and divide by this 3 is also there plus c. So what is the final answer? That is 2 by 9 times of 3x plus 4 to the power 3 by 2 plus c. Correct? So that is how we can find the final answer. Next, again we are expecting e to the power x, and here we are having 2x plus 3. So again x is replaced by linear function of x, that is 2x minus 3. So what we will do again, e to the power x is what? E to the power x, e to the power 2x minus 3 divided by coefficient of x. So coefficient of x is what? 1 plus c. So that will be your final answer. Correct now? Yes, please. A to the power 3x plus 2. So what you will do over there? A to the power 3x plus 2. Again, we are expecting a to the power x. So x is replaced by 3x plus 2. So what happens? A to the power x integration of a to the power x is what? A to the power x upon log a on the base e. Right? This is what we know. So integral of a to the power x is basically e to the power x into log of a on the base e. So in the same way, what we are having integral of in the same way we are having integral of a to the power 3x plus 2 dx. So that is going to be equal to a to the power 3x plus 2 upon log a on the base e multiply by coefficient of x divided by coefficient of x, that is 3, and plus c is also there. Plus c is also there. So that is your complete final answer. Okay. Next is please. Just try it by your own and then see the solutions. So integral of 8x plus 13 upon 4x plus 7 into dx, right? So I think we should try to make the numerator as similar to the denominator. So what we will do, integral of, can I take it like that, 8x plus 14 minus 1. 13 can be written as 14 minus 1, right? Divided by 4x plus 7, okay, into dx. So now what happens? That is going to be equal to the integral of 8x plus 14. So 8x plus 14, 2 can be taken as common out. So we are having, I think, 4x plus 7 and minus 1 upon 4x plus 7 multiply by dx. Correct? So now what happens? So this can be equal to integral of, yes please, separating the terms. So first term will become 2 times of 4x plus 7 upon 4x plus 7. Correct? Minus 1 upon 4x plus 7 dx. Correct? So I think these terms will be cancelled out. First term will be cancelled out. 4x plus 7 and 4x plus 7 will be cancelled out, right? So what we are left with, that is equal to 2 times of integral of 2 times of dx minus integral of 1 upon 4x plus 7 dx. Correct? So what is the first one? 2 times of dx, so it is going to be equal to x minus. So here what is there? 1 upon 4x plus 7. So we are expecting 1 by x dx. So 1 by x dx is what? Log x on the base e. So 1 upon 4x plus 7 is log of 4x plus 7 on the base e divided by coefficient of x, that is simply 4. So that is going to be a final. Next one, integral of tan x dx, integral of cot x dx. How will you proceed on that? So integral of tan x dx, so what we will do, that can be equal to integral of sin x upon cos x dx, right? So numerator, okay, denominator can be taken as function, so numerator will be its differentiation, right? So let us suppose that cos x is equal to t, so sin x dx is equal to dt. Correct? So let's put up its value. So what we are having? Integral of sin x dx is dt upon t. So it is simply integral of 1 upon x is what? Log x on the base e. So log t on the base e plus c. So now put up the value of value of t. So what is t? Cos x, right? So it is equal to log of cos x on the base e plus c. Correct now? So in the same way, you can also find out the answer for the second term, that is integral of cot x dx, right? So that can be written as integral of cos x upon sin x dx. Correct? So let us suppose that sin x is going to be your t. Okay. So if sin x is t, then minus cos x dx is going to be dt. Put up all the values. So that is going to be equal to minus of integral of dt upon t. Correct? So that is equal to minus of log t on the base e plus c, because 1 upon x integration is log x, right? So minus of log x value is what? Sin x. So minus of sin x on the base e plus. So that is how you are having the final answer. Correct? So I hope you understand the very basic things based on the integration by substitution. Alright. Next, we are having the list of formats, okay, and its substitution. So that formats and substitution you should remember directly. All right. So I have already shown you the list. So you should just note it down in your notebook. Okay. So whenever any such formula or any such equation is arises to you, then you can just simply make the following substitutions. Like in the first case, you are having a root of a square minus x square. So you can take x is equal to a sine theta or x is equal to a cos theta. Okay, then you can have the complete answers. Root x square plus a square, so x can be equal to a tan theta. Root x square minus a square, so x can be taken as a sec theta. In the same way, all the substitutions formulas are shown over there. So you should just make a list of it, okay, and remember it. And whenever you got such kind of expressions in your numericals, then you can just implement the formulas and have the final answers. All right. Okay. So, like if some example, if I'm going to show you like that, suppose you are having integration of under root of, suppose you are having integration of bx upon under root of x square plus a square, where x is a constant. Okay. So what is the substitution for that? The substitution for under root of x square plus a square is a x is equal to a tan theta, right? So just put up the substitution. Let us suppose that x is equal to a tan theta. So dx basically equal to a differentiation of tan theta is what? Sec square theta. So a sec square theta d theta. Correct. Now put up its value over there. So that is going to be equal to integral of dx is what? A sec square theta d theta divide by what we are having, under root of a square sec a square tan square theta, a square tan square theta plus a square. Correct. So a square is taken out from the denominator, okay, and a will be taken out of the denominator. So a upon a will be there, integral of sec square theta d theta upon what we are left with, tan square theta plus 1 under root of 1 plus tan square theta, right? So that is going to be equal to a cancel out. So what we are having, integral of sec square theta d theta upon under root of 1 plus tan square theta is sec square theta, and under root of sec square theta is what? Sec theta. Correct. So 1 sec theta cancel out. So we are having integral of sec theta d theta, right? So just you should solve this expression, okay, and put the value of theta. Theta is going to be equal to tan inverse of x pi. Theta is going to be tan inverse of x pi. Clear? So just put up its value in this expression and we will get the final answer. Alright. So that is how we can proceed. Next we have to understand is the integration by parts. By parts means when we are having two functions over there like fx into gx, right? So suppose we are having two functions like that. Integral of fx multiplied by gx. But remember that here in this case, while applying this formula, these two functions must be different functions, right? So remember that while applying this formula, these two functions must be different functions, not same variety of functions. Okay, like one is trigonometric, so another one will be logarithmic. One is algebraic, so another one will be trigonometric or logarithmic. Okay, so they cannot be the same. Algebraic, no, not possible. Logarithmic, not possible. Exponential logarithmic, not possible. Exponential logarithmic, possible. Exponential, not possible. Okay, same variety is not possible. Different variety can be accepted. Okay, so what is the basic formula? That is simply first into integral of second dx minus integral of differentiation of first multiply by integral of second dx the whole integration. Correct. So remember the formula very well. Differentiation of first into second is given by simply what? First into differentiation of second dx minus integral of differentiation of first into integral of second dx the whole integration. Correct. Now there is a rule that is called as IIT rule. Okay, I stands for inverse function. Inverse trigonometric function like sine inverse x, okay, cos inverse x. So I inverse stands for inverse function, L stands for logarithmic function, okay, A stands for algebraic functions, and T stands for trigonometric functions, and E stands for exponential functions. Okay, so this is the rule. Okay, IIT rule is the rule. Okay, so this decides that which function will going to be first function and which function will going to be second function. Okay, so suppose we are having a combination of a function, suppose x log x on the base e dx, right? So what combination we are having? We are having x means algebraic and logarithmic means L. Okay, so the function which comes first in this logarithmic, in this IIT rule, the function which comes first in this IIT rule will be taken as first function, and the function which is coming second will be taken as second function. Correct. So the priority will be decided on this order. On this order, we will decide the priority. So here we are having algebraic and logarithmic. Okay. So which is my first function? I think in this category, logarithmic L is coming first, and then A is coming, right? So logarithmic is coming first, and then the algebraic is coming. So I can take my first function to be my logarithmic function, and my second function to be my algebraic function, and then apply the basic formula. Alright, so what is my formula? It is simply first into integral of second dx minus integral of differentiation of first multiply by integral of second dx the whole integration. Correct now? So if I just solve this particular question, so what we are getting? So it is what? First means log x on the base e, integral of second dx, integral of x dx minus integral of differentiation of first. First is what? Log x on the base e multiply by integral of second dx means x dx. Okay. Multiply by integral of second dx x dx का whole integration. Dx. Differentiation of first dx multiply by integration of second dx का whole integration. This is what we have, correct? So that is going to be equal to what? That is going to be equal to log x on the base e integral of x dx. So integral of x dx is what? X square by 2 x to the power n plus 1 upon n plus 1 minus integral of differentiation of log x on the base e. So differentiation of log x on the base e is what? Basically 1 by x, right? Multiply by integral of x dx. Integral of x dx is what? X square by 2 का integration. So that is going to be equal to log x on the base e multiplied by x square divided by 2 minus 1 by 2 is taken out. So 1x cancel out. So we are having only integral of x dx. Correct. So it is going to be equal to what? Mhm. X square by 2 into log x on the base e minus 1 by 2 is taken out. Integral of x dx is what? X to the power 1. So x to the power 1 plus 1 upon 1 plus 1. So x to the power 2 upon 2 plus. Correct. So that is how we can proceed into the such kind of numericals. You understand how does first and second is decided? First and second is decided on the basis of right IIT rule. Okay, the function which comes first will be taken as first. The function which comes second in the IIT rule, which will be taken as second while doing the integration over there like that. Clear now? All right. So next is the last section that we have to see is the definite integrals. So let's see about definite integrals. Okay, so definite integrals means within the proper limits. Okay, so suppose you are having the integration of suppose x square dx within the proper limit. Suppose 3 to we are having the proper limits within suppose 2 to 3. This is what we are having. Okay, so to find this value, first of all you should just integrate as it is. Okay, so what is the as it is integration? X square is what? X to the power 2 plus 1 upon 2 plus 1 within the proper limits. What is the limits? 2 to 3. So that is basically going to be equal to x to the power 3 upon 3 within the proper limits 2 to 3, right? So now how to solve this? So in place of x or variable, whatsoever you are having, so in place of variable, what you will do, you will just put up the upper limit first of all, and then you should put up the lower limit. Okay, this is what we will call as upper limit. This is what we will call as the upper limit. Okay, and this is what we will call as the lower limit. All right. So what you will do in place of variable, just put up the upper limit minus lower limit. Okay. So what is right? So in place of x, just put up the upper limit. So it is going to be 3 to the power 3, and then minus put up the lower limit, that is 2 to the power 2. And the constant term is again put up as it is. No issues in the constant terms. That is 3 plus. Okay. So that's going to be equal to 3 to the power 3 is what? 27 minus to the power 3 is to the power 3. So to the power 3 is going to be equal to 8 divided by 3, right? So 27 minus 8 is what? 19 by 3. So that will be your answer. So do you understand how to put up the integration in definite integrals? How to put up the limits? So whatsoever function you are getting, just put up the upper limit first of all on that function in the place of x, and then put up the lower limit in that function in place of x. Or you can understand this like that. Suppose if integral of fx into dx from the limits a to b, it is going to be equal to gx, right? And now you have to put up the limits from a to b. So what you should do, just put up the value of b first of all, g of b in place of x minus, then put up the lower limits, that is g of b, like that. So that is how you can find out the final answer. Have you got it? Suppose you are getting another example on the basis of that. Suppose you are having integral of sin x dx from the limits 0 say pi by 2. Correct. So sin integration is what? Minus cos x from the limits 0 to pi by 2. So minus upper limit. First of all, in the place of x, put the upper limit. So it will be cos pi by 2 minus cos 0. Correct. It is minus of cos pi by 2 is cos 90. Cos 90 is 0. Minus, what is the cos 0? It is 1. So minus minus 1 is this one. It is your final. Correct. So this is how we can find the definite integrals. Okay. So all right, everyone. So this is all about for integration. So I hope you understand very well how to apply the integration, how to do the problems related to integrations. Okay. And this is how the integration use up in your physics. Okay. So just revise the class again and again. Okay. Unless and until you got the complete gist and complete basics concepts of the integration very well. And then just solve out any of the numerical book based on that. All right, this is all the basic integration which will be used up in physics. Okay, in any kind of the examination if you are targeting like JEE-Mains, Advanced, NEET, AIIMS, okay, or 11th standards boards exams, CBSE exams. So that integration is really helpful for you. Okay. All right, everyone. So if you like the videos, then just subscribe the channel if you didn't have subscribed yet, and just like the videos and share with your friends and make them know about this. Any suggestions, any thing you want to share, then just comment over there. Okay. All right, everyone. See you in the next class with the next topic. Goodbye.